So hello and welcome to Python Maven this time, right? This is the name. The full name of this channel, of this group is Code Mavens. But now that I do all kind of various languages, so I'm calling it Python Maven or Rust Maven. My name is Gabor Sabo. I'm sort of the host here this time. So welcome to the meeting. And if you're watching the video, welcome to the video. And if you're like the video and follow the channel if you're watching the video. And I don't want to talk anymore here. So I think I'll give the place for Tamar, who is going to give the presentation. Then feel free to ask questions in the meeting in the chat. I'll try to monitor that and ask Tamar. And after the video, we will stop the recording, and then we can also have a freer chat with you, all of you contributing without the recording, and that would be interesting because the recording is going to up to YouTube. Okay, so welcome, Tamar. Please go ahead.
So, hi everyone. So I will start by introducing myself. So currently I'm a team lead in the research group at Ox Security. Ox Security is actually an application security company. So it's kind of combination of the connection between developing and making and ensuring that the code that like developers are writing are secure. My background is from the development. I started coding when I was like 13 years old. So I'm 27 years old right now, so it's more than half of my lifetime actually that I've been coding. And yeah, I always was curious about building stuff. In the past it was a Lego, and now it's in code. And in general, I love memes, so hope that you love them too in my presentation. My main language nowadays is Python, but I code in C#, in Java, in C, in C++, and of course Bash scripting and all of those stuff. But currently, I'm writing most of my code in Python. So cool. So how it started, 2 years ago, I joined Ox Security, and my previous job, I was working in an on-prem company, and I wasn't aware of security at all. And one of the first missions that I got in my company was to build a unified logger to make it a Python package. So we will have it in all across all of our services. We'll use the same unified logger. And this is how I started to look more and dive into those like to look over all the logs that we had in our system and start to replace them. And I noticed that we as developers, we really love logs. They're really easy. We just put them everywhere. They have like a wide support everywhere. If you don't if you want to filter some data that you don't want to see, it's really easy. We have a lot of like systems that are making our life really easy. It's really easy to filter out everything that you don't want to see. And in this and it make us to don't think very much before we even write our logs, because it's so easy to filter out. It's so easy to just choose any infrastructure to just make like smart selections, and it's really easy and intuitive to use. So when we actually log, so the first case, like the easiest case, is when we just want to understand what is happening in our program, right? We just want to follow along what is actually happening, and we just want to print this happened now, and then this happen and just follow our code. The second case that is common is when we want to just track which errors or like which um, unexpected things are happening. So we're just logging everything out and just putting as much data as we can in the log. And it's really easy to just like who is not using print debugging instead of actually a real debugger. So it's really common thing to use, and sometimes it's not just print, it's with logs as well, because you don't want to see it only like on your local machine. You want to commit this code, you want to see it like in the production environment, so you're actually putting logs for debugging purposes. And the third case that I noticed that is happening, that sometimes you want to like document some edge cases. Let's say that you have a function and you know that you might have some weird case and you're not sure how often it's going to be in real life, right? You know it might happen, you don't know how many times it's going to be. So we're not going to handle it right now. Let's just add a log so we will be able to measure how often it's happening, and then we will decide if we're going to tackle this edge case or not. I try to like match those type of logging into like the log levels. It's not like accurate. We can debate on each log level and what is its purpose, but like roughly when I think about logs and what like they're trying to do, this is like a rough thing that I did. But so this is like the introduction about like logs in general. Okay, so logs, this is really cool, really nice. So what can go wrong? Why we are talking here about logs? What is so interesting about this like really simple mechanism that we all know and we all use? So the first oops that I'm going to talk about is a famous one by Twitter. It happened really like a few years ago, but what happened in this case is a worker of X, Twitter, by then just leaked in plain text all of the users and passwords in one of the internal logs of Twitter. It was a really big incident. Everyone was asked to update their password, and this happened like to a really big company like Twitter. A few years later, and also Travis CI exposed by logs, credentials, and this again another like big data leak that happened by people that accidentally just log some really sensitive data. So when we are thinking about this, this is not something new. Back in 2006, Maitre, with like an organization, or I don't really like, I think it's an organization that like gives a description to all of the common vulnerabilities and like common weaknesses, define this common weakness of insertion of sensitive information into logs. This is like something well known. This is not something that is new in any way, and we see that these kind of incidents are still happening. We see that even like we are almost 20 years after this CWE was defined, but we still have some cases of those leaks. So let's get to us, to people who write code, why this is still happening to us. Why it's so easy to miss in this type of simple task, and what is happening. So The first case that sometimes when people are writing code, they are testing things only local on their machine, and they're not always looking how their code is running in the production environment. So when you're testing on your dev environment, you are probably using mock data. You are probably not viewing all the flow. You are just testing only the part that you currently want to see. And you are not putting real data. So it's not something that is popping up when you're testing your local work. And this is the first case that is happening. The second one, what developers care about. So the amount of time that I've been in discussions about linting, about should I put should I do the enter here or enter there? Should I use this type of linter or this type of linter? Like this is a really massive topic of how we should lint our code. This is something that I noticed that most of the developers really love to talk about, and especially love to discuss and debate about. The second part that is like the core of what we are doing is actually having the logic of our code work, to have like the functionality as needed, to have the right design, to have the right patterns, to have like everything as we want it to be. And I think that like the third part of the security sometimes is forgotten. Sometimes we are not as aware as the other parts of like when we are coding. So this is something that sometimes we tend to miss. Cool. And of course, we want to just deliver fast, right? We want to write code, we want to have it on production, we want just to get things done. And having security review or having anything in the pipeline is making everything slower, and we want just a fast delivery. So sometimes we're just skipping some steps. Maybe we're skipping also tests like unit test, maybe we're skipping review, and maybe we're skipping security review as well. So those are like kind of things that I noticed that might explain how like big companies like Twitter or Travis CI came into those situations. Now what I want to show you is like snippets that I found from real code, most of them open source. I changed it a little bit just to make it a little bit more clear. And let's see what is problematic in each snippet. So let's go over the first snippet. We're seeing a simple Python function that is trying to run some sub-process with this command of git config. And in first, like in like a first glance, when you are looking at this code, maybe you can see like some other problems. Maybe you don't know if this URL is a safe one. I don't know. You are seeing that you are having this access token. I don't know. But the real problem here that is easy to miss when you are just looking at a glance at this code is that you're actually just printing in plain text here this access token, because you just print the command as it runs with all of its parameters, and it contains here, as you can see, this token. If you know good GitLab access token, you will notice this is not a real GitLab token, so don't you worry. I just mocked everything to prepare to this talk. This is not real secret. So don't try to steal it and do anything with it. But if you're going to run it on real production system, you will expose real GitLab tokens by running this code. Another example is when you are like using, maybe you are using some APIs that some I don't know, other team wrote, and you're not like know exactly what you're going to print. You don't know the widget client so good. And now when you're printing it, so someone just, I don't know, implements the wrapper function or the str function in this way, I don't know why, and you're not aware of it, and you're just printing it in the logs. And again, we came to the same situation that, again, in first glance, in both of the cases, it's something that it's really hard to identify, and it's really hard to stop by yourself. Okay, so yeah, it is a problem, but we already have some kind of solution to this, right? We have like some kind of scanners that can scan the code and find like secrets, right? Like, okay, we know this problem. Yeah, you convinced us, but we don't need anything new. We do already have this solution. For example, there is a great open source project. It's called Gitlix. If you don't know this project, I really highly recommend you to look on it on GitHub. It's a open source project that can scan your code and just find any secret and just find any like sensitive information or any password or any token. And the great part of Gitlix, as its name can tell you a little bit, it can scan also your Git history. So even if like you had some secret in the past and you delete it, but it's still in your Git files history, it will still pop up. So it's actually a really cool tool. So great. So we have this kind of tools. So what else we need? The problem is, and here we need to pay attention, that sometimes those secret values that we are going to log are not actually present in the code base itself, right? Sometimes we're doing everything right. We are storing all the secret data in a, I don't know, in a KMS or in any like secret vault, and we're not using anything that can be potentially dangerous, but still on runtime, only on runtime, when we are logging the secrets, we're going to expose these secret values. And this kind of problem, Gitlix cannot detect. And any secret scanner cannot detect, because in those kind of scanners are just scanning the code statically and not in runtime. So you cannot identify that you have a secret in development time. Okay, and this is what we want to. This is like the goal that we want to achieve. We don't want, after that we release our code, to have some scanner that is running and detecting everything. We want our solutions to be to prevent them from the first place. We don't want it to be too late, because if a scanner already discovered that we had a leak, it's too late. Cool. More memes. And you know what is making everything way worse? That who has access to your log? Everyone has access, right? Because everyone in the company should have access to the log system. It's not something that is built for really complex permissions. Logs is like your log system is not something that's built for having like sensitive data. So even like, let's say that the QA team and the integration teams and maybe even sales teams, everyone have access. It's really easy to get. So it's hard to control who can see this data, and it's hard to control who consume it because you just can read it. You don't need to download any file. You don't need to do anything. So let's just summarize what we saw until now. It's really easy. It's really easy to put accidentally secrets in your logs, and everyone in your company can have easy access to this, and this leads to a fine situation where everything is on fire, but you think that this is fine. I hope that until now I was able to convince you that we need some solution that will help us to prevent those kind of issues without interrupting our development cycle and without like causing a lot of changes and breaks in our code. And exactly for that, I created the masker logger that will answer all of the problems that I talked about them earlier. So masker logger is some kind of logs that will prevent you to just give away your sensitive data. Okay, so let's go and see a demo, and let's just start. So as you can see, a really simple Python program, and we do get some environment variables from the N file. As you can see, we just printed in plain text some secrets. Again, those are not real secrets, don't you worry. And now the only thing that is going to change in this log, we're going to add a simple import. And we're going to change our formatter to the masker formatter. And we're going to run the same code again. And now those secrets are masked. Cool. Okay, so let's talk about a Python logging module and how this module is working. So the logging module is a built-in module in Python. We have the logger itself. Each logger can contain different handlers. You can have a like handler for sending your logs into a file. You can have to send it to the std out, and each handler has its own formatter. In which format you want to write your logs? Maybe you want it to be with I don't know, the date, the log level, and then the message. Maybe you want it to be, I don't know, only the message. You can just change the format of the log itself. And when I designed this solution, I want it to be, I want to change as less code as possible in order to make it as flexible as possible. So I chose to just override the format function of the logging module. So it's really easy. You can like with like each logger or handler that you're using, you just need to override the masker logger and you can still set any handler that you want and any logger that you want, and you just need to change the formatter. So you don't need like to install a new logging tool. You can just use the own Python logging, and each like if you're using another logging module, but it's inheriting for logging for Python logging, it's going to work as well. So it's like really flexible. Cool. So let's dive in a little bit what is actually happening behind the scenes and how like this tool is working, because no magic here. I'm going to reveal all of my secrets. It's open source, of course, so you can see it by yourself. But when we create a new instance of the formatter, few things that are happening. First of all, if you remember, we have this gitleaks project. Gitleaks have a configuration file called gitleaks.toml, and it's actually a big file created by the community with a lot of signatures that should grab different secrets or different like sensitive information. The second part, we create a map between keywords that we're going to talk which keywords we are going to map into the regex like the Gitlix toml is like just a like a list of a lot of regex, and then we create some automaton. We will dive into each step, so it's fine if it's not clear yet how this mechanism is working. So just like uh, to talk about the automaton, we are like creating automaton to each keyword to have like a really fast matching. We're going to talk it a little bit later. Cool. Okay, so during runtime, what we're doing is we are overriding the format function, okay? Then we search for a match, and then we are performing the actual masking. We're just doing find and replace with asterisks and a really simple logic there. So let's dive into each step. So Gitlix.toml, as you can see, is like a file, uh, again, open source, created by the community, that have a bunch of rules. Each rule is in the following format. We have an ID, okay, of the rule. We have a description, we have a regex, and we have a keyword. The parts that we are interested about are the regex and the keywords. The regex is, as you can see, a really complex regex that should catch only the Atlassian API token, for example, and it should be accurate only to that. The problem that we have is that matching regex is a really expensive and time-consuming operation to perform. If we're going to try to match each regex in this file to each word that we're printing, it's going to take us forever. This is something that we want to avoid. So for this purpose, we have those keywords. Those keywords are telling me that if I don't have one of these words, one of these strings in my string, I don't even want to try and match my regex. Okay, this is like a first tier filter that is telling me should I even run my regex or should I not. Okay, so how I'm actually performing this kind of search. We are building this automaton of all the keywords that we have using the Algorithmic algorithm. It's an algorithm for matching in a really fast way keywords. And then we have our map that we pre-build, and we're getting the needed regex, and then we're running only the regex that were matched by those keywords. So just again, just to explain the part of the algorithmic and the keywords searching, how our crossing is working. We are creating a really big, like a state machine of all possible words in the map of all the keys. And each time we are searching by just traveling or like traversing this kind of tree or like a state machine that we have. And if we are ending in a like a leaf, we know that we find a match. And if no, we are saying no, we didn't find a match. So it's really a quick way to search a lot of strings in one time, because you're just running through all over your state machine and finding the needed matches. Cool. So in terms of runtime, as you can see, we do have some penalty. Yeah, we do have some runtime that we're taking, but it's not too bad at all. And now in terms of security. So like in things that we should maybe think about. So redos if is a type of like a attack that you can manipulate the input into what regex you're going to look, and this can cause to like infinite loops. There are like some kind of regex that you can manipulate, and with some type of input that you can cause infinite loops. So if someone is putting some config, like some gitlix toml config files that can exploit this kind of a situation, it can be dangerous. We did a simple things with that. We just put some timeout. So if the match is not ending after, I think, 1 second, we're just we are just throwing a timeout exception. So this is how we prevent this kind of problem in the tool. And the second thing, it's not a it's like not a really big concerning, but sometimes you don't even want the people to know what was the like actual length of the secret. Even the length itself can like give you some information, so you can control the length of the masking if you want to. Cool. So what next? So first of all, just take it under consideration. I don't know if like the snippet that you saw before, if it's popped out to you that yeah, we have some problems there. But when you're writing code, just put it under your mind. And second, you can use it. It's an open source project. Of course, you can contribute to this project, maybe expand it to Rust as well, and maybe to other languages that don't have this kind of loggers yet. And actually, this is this is what the tool is. I hope that you enjoy and learn something new. And thank you very much. And we have actually a lot of time for questions. So if you have any.
Thank you, Tamar. I just wanted to remind everyone that we are in recording. So if you'd like to ask a question, and if you don't want to be in the video, then just type in your question or wait till we stop the video. But if you'd like to ask questions, that's the time. Thank you. People are silent now. Okay. Okay. No, just go ahead, Maur. Just ask a question. Oh, wait a second. You can't. Okay, I'll just have to change it so people can turn on allow participants to unmute themselves. Okay, sorry, I forgot about that. Okay, so go ahead now. You can just ask your question.
Hi. First of all, great talk. Thank you. I love the memes. Very important part of the talk. I wanted to know what I mean. The logger works line by line, right? So if someone had the triggering keyword on a previous line of the log and then the secret, it wouldn't trigger, right?
Yes, it's a limitation that like the GitX mechanism itself. You can, if like you have a specific case, the logger itself have the possibility to have its own configuration file. Like inside of Ox, we change a little bit the open source version to our version. So you can remove some of the keywords, you can add some of the keywords, but yes. If you know like a specific case, you can do a workaround, but in general, it is a problem. I will say that it's kind of uncommon to have two logs lines one after another. Like I don't see it very often. Like most of the people are just logging in one line, but yeah, you are right.
Okay, thank you.
Okay, another question I'm going to read out. Can't secrets of Atlassian, for example, be in a line without any of the keywords?
So, I gave one example, but some of the secrets themselves, like inside of the secret itself, like some of the keywords are not like a word that should come in like before the line or something like that. They are part of the secret itself. Like if you will notice, GitLab token will always start with GLPT. So this is a keyword for GitLab token. GitHub as well have some kind of a structure. AWS again have some kind of structure. So some of the keywords are like for matching words around, like in the line, and some of them are for searching words of the secret itself.
Anyone else questions? It's time for the questions. We can. Well, if there are no more questions, then we can stop the video recording. People can stay around. And first of all, thank you for everyone who participated, and especially thank you, Tamar, for this presentation. I really enjoyed it. And those people who are watching the video, please like the video and follow the channel. And under the video, going to find a link to the website where I'm going to put on links. I share the links of this project you mentioned in the chat, so I'm going to put it on the on that page. And also your contact information. So if people would like to get in touch with you, then those are the ideas. Thank you very much again. And I'm going to stop the video now. Okay? So bye-bye. If I can't find the button. Yeah, I'm still looking for it.
I can do it by myself because I'm co-host if you want me to.
Yeah,